인공지능과 인간이 이제는 조화롭게 살아가야 함은 자명한 사실인 것 같습니다. 받아들여야 될 사실인 것 같은데요. 그렇다면은 인공지능과 인간은 어떻게 공존을 할 수 있을까요? 자, 두 번째 기조연설 함께 하시면서 그 해안들, 해법들 짚어보도록 하겠습니다. 자, 이번 자리를 위해서 또 귀한 시간을 내어주셨는데요. 마이클 조던 미국 UC 버클리 전기공학 및 컴퓨터학과 교수님, 그리고 진행에는 차상균 서울대 데이터 사이언스 대학원 원장님께서 이번 세션 진행을 해 주시겠습니다. 인공지능과 인간 어떻게 공존할 것인가라는 주제로 이야기 나눠보도록 하겠습니다. 자, 단상에 두 분이 나와 주셨는데요. 여러분 박수로 환영해 주시기 바랍니다. 네, 진행 부탁드리겠습니다.
Welcome to the keynote session with Professor Michael Jordan from UC Berkeley. I'm Professor Sang-Kyun Cha, the founding Dean of the Graduate School of Data Science, Seoul National University. Now let me spend a few minutes to introduce Professor Jordan. There are two distinguished Michael Jordans in the world, and the younger one with the middle name Jay is a well-known all-time basketball superstar. Today's speaker, Professor Michael Jordan, has a middle name I. Obviously, I precede Jay alphabetically. He is also legendary superstar scholar in the field of machine learning, cognitive science, statistics, electrical engineering, and computer science. And overall, we can call his field data science. He did his PhD in cognitive science at University of California, San Diego, with David Lumelhart, who is also a great cognitive psychologist. He was a professor of MIT for 10 years from 1988. Then in 1998, he moved to UC Berkeley, currently holding two positions, one in statistics, another third position in electrical engineering and computer science. What is amazing about Professor Jordan is not only he himself made a big contribution to the foundation of machine learning, he also nurtured so many outstanding scholars as a student and postdoc. I can mention two, Joshua Benjo and Andrew Ng, who frequently come to Korea. And others are found in the top academic institutions such as Stanford, MIT, Carnegie Mellon, Princeton, Columbia, Cambridge, etc. While what I like about him is he's a very conscious scholar and outspoken critic of misuse of intelligence and artificial intelligence. We will hear his views shortly. I met him at Tsinghua University last year during Korean Thanksgiving. He was distinguished professor at Tsinghua, and he also similar position at Beijing University. I'm particularly excited to have a Professor Jordan in this forum this year. Actually, 3 years ago in this forum, I spoke the slogan of raising million digital talent for the nation to prosper. We are in the first step of this transformative move. I mean, I personally am very proud and pleased to start the new graduate school at SNU to promote a democratization of data science education and research. UC Berkeley is a pioneering institution in this direction, and we are very pleased to have a Professor Jordan here today to listen to his views on machine learning and what others call AI, and the future direction of research and education. I appreciate him very much for coming to Seoul all the way for this forum. This is his first pandemic speech with the physical audience in this room. Now let's welcome Professor Jordan with a big applause.
Good morning, and thank you for having me visit you here. I'd like to thank Professor Kuhn for the very nice introduction, and I'm very pleased to be at this event. I think that thinking about HR together with AI is a very, very useful thing to do, very helpful for orienting our thoughts about what's going to come and what we want out of AI. So I have some strong feelings about AI. I've been working in it for 30 years. And I've been somewhat dismayed about the misconceptions and the mythology that's been building up around it in the last few years. So I want to talk a bit about that. I think it's important to pull down some of the heat around this topic and pull down some of the wild dreams around the topic while still inspiring young people to work in this field. All right, so let me go ahead and begin. I do think that words like data science are in some ways more appropriate for this overall effort. It's not just about magic intelligence in the computer. We don't have that, and we won't have that in our lifetime. We do have is an emerging engineering field that uses computers in new and powerful ways. It uses data, and it uses human ingenuity and insight. And I'm also going to emphasize it uses principles of markets. This is really about bringing data and markets and humans together in new ways. Okay, that's really what it's about. So I'll say a bit about what artificial intelligence is, what it's not, where can we expect it to go. And let me just first of all say, it's not really a good idea to call it a technology. It's not a thing. It's not a single entity, AI and something else. It's a engineering discipline. It's something like electrical engineering or chemical engineering in the 40s and 50s, a century ago. It's a field. It's a way of thinking of building systems, right? That's a better way to think about it. It's not just a piece of technology. All right, so the original usage of the term comes from the 1950s. John McCarthy created the terminology. His perspective was one which I call human imitative. The goal or the aspiration was to imitate the intelligence of a human in a computer. It was an interesting philosophical aspiration. Okay, can it be done? Is it possible? Okay. Before that, there hadn't been computers, and now there's computers. So there's hardware and there's software. It seems like the brain and the mind. Can we think about what this parallel is like? So it's still an interesting aspiration to think about, but it's not really what's happened. We have not created McCarthy-style artificial intelligence in the computer. Our computers are nowhere close to being as intelligent as humans, and they won't be in our lifetime. Many other things have happened, but not this. Okay, so you have to be clear on that. What has happened? Well, a couple of things have happened that are just as important and interesting. One of them is what is sometimes called intelligence augmentation. There have been various people associated with this. This perspective is one that emphasizes the computer helping humans to understand the world around them. For example, a search engine organizes the world's knowledge in a way that makes it easier for us to access things about the world more quickly. Our memories and our thought capacities are expanded by the presence of a search engine. Even something like artificial intelligence used for natural language translation. It's not really understanding the language, but it translates from one language to another. That helps us communicate better between humans. Okay? So that's going to continue on. This has really been the last 30 years. This is what's really has happened with computers doing data analysis, is augmenting human intelligence. What I think is emerging right now already is something that I sometimes call II, intelligent infrastructure. So think about transportation, think about commerce, think about Alibaba or Amazon. They are changing the world using data analysis and using human data analysis in particular, and providing new services to people. And sometimes it's good, sometimes it's bad. It's complicated. And thinking about how to build those kind of systems so they really work and really bring value to humans is hard and an interesting challenge. So I think this is really more what's happened than what we mean by AI. If you think just about human imitative AI, which is an interesting philosophical goal, but I'm not so sure it's really a good engineering goal. Why should we replace a human with a computer? Humans, there's already billions of us. We're very smart. We do good things. What good would be gotten by taking a computer and putting them where the human is sitting? Okay, let's do new things with computers, not just replace humans. And so in fact, if you look at human capabilities like in vision, computers have gotten much, much better, but they're not nearly as close to humans as sometimes it's thought. So understanding the visual scene, thinking about the verbs that describe a scene, movement in the scene, what's going to happen next, those are things humans can do, and the computer's still very, very far behind. Very, very hard to think about that. It's good about thinking about the nouns in the scene. Is there a person? Is there a bottle of water? Things like that, labeling the scene. And similarly for some of the other topics, I don't want to spend much time on this, but natural language processing is perhaps the most notable one. Our ability to understand deeply the social and physical implications of language, the semantics of language, is far surpasses what a computer can do. Even a 3-year-old child far surpasses what a computer could do. It doesn't mean it's impossible to bring semantics into the computer. It's certainly possible. We believe that. But it's going to take 100 years or 200 or 300. It's very, very, very challenging. Okay? It's very deep. Robotics. Sometimes when you talk about AI, you have the picture of a robot touching a human. Robots are very important. They are making it possible to pick up a package and move the package from here to here, pick up objects of different sizes and do that. So factories can be transformed. We're still very, very far away, though, from having robots really interact with us in a deep way in our lives, in our homes, doing things that are more than just a toy. All right? So I still believe that it's interesting, but it doesn't mean that it's transformative. All right, and so in my view, in our lifetimes, we're unlikely to see AI of the kind that sometimes is dreamed about, something that is remarkably more intelligent than us, all right, or even as intelligent as a child. So what we're going to see is naive systems that can do a few things, that maybe can respond to a telephone call, or know some facts about the world, or answer some questions. But to really interact with us in a deep way over long stretches of time and understand our desires and our plans and help with those things, we're not going to have. All right. So are there things still worth worrying about even though AI is limited? Yes, even though it's limited, it's vast, it's large, okay? It can do lots of things tirelessly. Already computers are much smarter than us at certain very boring things, like knowing all the digits of pi. Okay, or adding up huge numbers, right? They are already smarter than us. But what are the implications of this? Well, there will be systems that seem smart, but they're not actually really. So a system that can translate from English to any language seems very smart. The system that did AlphaGo and beat the champion Go player seems very smart because it's doing a task that humans find difficult. But it did billions of searches on hundreds of thousands of computers to find the optimal thing to do in each situation on a limited board with no stochasticity. Okay? It's a trick in some ways. It's an exhaustive search. Right? It's not intelligence. Humans are far more intelligent on things that matter to us. For example, coping with uncertainty in the world, which is true of all of our lives every single day. Okay? And there's going to be loss of jobs, but I want to talk about that because it's not necessarily going to be loss of jobs if we think about it in the right way. If we think about it as creating markets, it's different than replacing humans. So my view that human imitative AI, even though it's the history and it's an interesting thing to think about, it's not the right goal. Okay? An overall system does not have to have intelligent agents inside of it to be intelligent. Okay, an economy can be intelligent. The economy that brings food into Seoul every day is an intelligent system. It's just not a classical artificial intelligence system. Each entity inside of it is doing something very simple. The overall system behaves well. Okay, that's a better way to think about it. Also, autonomy. Having a robot on the stage which autonomously does something is a nice Hollywood trick. It's very impressive looking. It makes us excited that the robot seems to be doing something all by itself. That's not what we want. Even think about self-driving cars. We want entities that interact well with other entities. All right? A car, if it's self-driving, should interact with all the other cars so they know where each other is. Just something like the air traffic control system. That's a better model for intelligence. Not a super intelligence that somehow knows what it should be doing. Not a Donald Trump style, but rather a Joe Biden style intelligence. All right, so in fact, if you think about intelligent systems on the Earth, most people only think about brains and minds, and our goal should be, as computer scientists, to mimic that. It's an interesting goal. I don't deny it. It is, and it should go on. all right? But there's also things like markets, which have their own principles of interaction and lead to intelligent, robust, adaptive, useful systems. Bringing those ideas into the computer science is already a very useful thing to do. And bringing computer science and data analysis into markets is useful. That's really not been done very much, okay? Most game theory analyses assume you know everything about the preferences of the humans. Instead, if they're being learned, that's a very interesting new way to think. All right, so if this perspective is true, AI and machine learning should have developed separately from classical human-imitative AI, and I think it has. So I think the real story of ML and AI goes back 3 decades. Already in the 1990s, there were companies like Amazon and other big companies that used data analysis and tens of thousands of computers and machine learning algorithms, things called random forests, to do supply chain management at scales that had never been done before, to do fraud detection at scales that had never been done before. It made e-commerce possible, okay? If you don't model 1 billion products by 100 million customers and make sure that each product gets to the customer within a day, the only way to do that is to analyze vast amounts of data. And they did that already in the 1990s, using exactly the tools that we talk about now as AI. Okay? No difference. The second generation to me was when it was realized that a lot of the data wasn't just about ships crossing the ocean and logistics and all that, it was about humans. It was about purchases and transactions. And so you could model that and make things like recommendation systems. See what purchases you've made, see that someone else makes similar purchases and recommend some of those purchases to you. And that makes commerce go better. It's interesting, okay? And it has had $1 billion impact on industry. The third generation is what I refer to as pattern recognition. It's noting that some of the data is not just about transactional behavior of humans, it's about speech and vision. And trying to imitate that is the current wave of hype around neural networks and deep learning. Very interesting. Still not a $1 billion industry, however. Okay? It's not clear what the industry will be built on that. In the meantime, I think that markets are emerging as a more important $1 billion industry that's developing right now and is using these kind of ideas. Okay? So you have to think about economics ideas and markets when you're making decisions in the real world and there's scarcity. Okay? Classical AI systems didn't think about scarcity. They thought you could do anything you want to because it's all inside the computer. There's no scarcity. In the real world around, there's scarcity. What do I mean by that? So let's think about a classical recommendation system. I think you all know what this is. You go to buy a few books on a bookseller website, Amazon or something. After it starts to recognize the pattern, it maybe says, you're like this other person, and I will recommend their purchases to you. We all use this. It's very effective in some domains. It's very effective. In other domains, it's not so effective. Right? And this is what I want to get at. All right, suppose you've built a recommendation system for some new product, all right? And you want to start making recommendations to not just a small number of people, but large numbers of people. Maybe all of Korea is going to use your app, all right? So it's going to make recommendations for decisions taken by real people, all right? If you're recommending movies, it's perfectly fine. You can copy the movie as many times as you want. There's no scarcity. If you recommend books, you could even copy the books as many times as you want. But if you recommend restaurants to people, you will send too many people to a given restaurant, and you will create congestion. There'll be a line. You created it. If you recommend paths to the airport that are the fastest possible, if it's only a small number of people using your app, no problem. As soon as many people start to use it, more and more people use it, you created congestion. You created a problem that didn't exist before. All right? If you recommend stock purchases to people, and I started to think about this when I was first going to China. There was all of these services recommending stock purchases because people had some money to invest for the first time in their lives, right? If you're doing that at the scale of 1 billion people and you recommend the same stock purchase to 1 billion people, they all buy the stock shoots up in price. You destabilize the market, okay? Big problems like this, all right? And you can't just regulate these away. You have to think about what is the market I'm creating here with its data analysis at this scale? And that is the kind of interesting problem of AI that's emerging. How do I create these new kinds of markets which are based on data flows and valuing data flows? All right, so I'm going to give an example which I dear to my heart. I'm a musician in addition to be a professor. And if you think about music, many people are listening to music now. All the young people are listening to music all the time. Many people seem to be making music. It seems like there must be a wonderful market happening. And the answer is there's no such market. The people making the music are not getting paid for their work. All right? You might think it's the few famous musicians, Beyonce or K-pop, everyone's listening to their music. That's not true. If you look at the data, 95% of the music being listened to today is being made by not famous people. People you never heard of who made the music on the computer, uploaded it, and it got streamed to people. And that's what people want to listen to who really love music. They don't want to listen to just the famous stuff, right? But those people who are making good songs and uploading them are not connected in a market. They're not getting paid. They have no career. They have no career. That's tragic because they are bringing economic value to the world, but that economic value is being left on the floor. All right, so how do you fix this? You fix it by realizing this is not just streaming of bits and intelligence on the computer. This is a market that could sit there. You could create a dashboard for musicians that if I'm making music, and I'm pretty good at it, people listen to it, at the end of the week, I see a map of Korea. And in the map of Korea, there's a dot every time someone listens to one of my songs. Right? Now I know that in a certain city, I'm very popular. I can tell the venue owners there, look at the map. I'm popular in your city. Can I give a show there? They bring me, I give a show, I make 20,000 euros. I do that 3 times during the year, that's a salary. I'm also connected to the people listening to me. I can offer to come play at their wedding. Okay? I can offer to have them come backstage. I can create markets that are very creative as soon as you make the connections happen. And those connections are completely absent from our current world. Why? Well, partly companies never thought about that. They think that advertising is the way to make their money, not connecting people to people, right? So they make advertising dollars. Bad idea, ruining our world. Much better to connect people to people and let the value flow, and then you can take a transaction fee if you're a company. You can make money still by doing this, all right? There's a person in the United States named Steve Stout who's actually doing this, and he has a company called United Masters that you should go see. It's got 500,000 musicians on it now, and their music is being listened to on websites like the NBA website. And he has partnerships with AT&T and Verizon and all. So this is finally starting to happen. And that company will be, I think, a very big player in the world. And you don't have to do this just once worldwide. It can be done separately in every country. Korea has a music scene, obviously, and you could empower more musicians. I can imagine 1 million people in a country the size of Korea doing this kind of thing and making some money off of their work. I can also imagine artists or writers being connected to people who they're writing for or drawing for or creating for. All right, so the consequences of thinking this way is that you can use data and computers to create new markets and therefore create new jobs. It's simple in some level, but it's not talked about. And most of the business models in Silicon Valley and elsewhere are not based on this. Social networks were not really about connecting people. They were allowing people to put some things up there and use advertising to make money. Okay? It should have been about information flow between people. I could say ideally to Facebook, I'm going to Seoul next week. I've never been there before. Could someone tell me what's interesting for people like me? I can't find that on a search engine. I can't find that on Facebook right now. Wouldn't it be wonderful if one of you said, hey, I know, I'm like you. I see your background. I'm very similar to you. And then write a 2-page document, and then I pay you for that. If a system could be set up to happen at scale, have that happen at scale, that would be transformative. Okay? So I believe the companies that are actually doing something like creating markets are the ones that have been the biggest successes in the last 10 years. I think that Alibaba and Amazon are examples of real success. They're connecting producers to consumers. They created new markets. Uber is another example, maybe less success, but it's an example. And I think some of the companies like Facebook and Google are not a success. They're not creating a new market, and I don't think they're innovating. I think they're making lots of money from advertising, but I don't think they're innovating and bringing a lot more new value to people ever since they did their first search engine or their first social network. Okay, so if you want to think about AI, think about it as data science, which I really think is a fantastic terminology, and algorithms, and bring in markets. And now you start to talk about powerful ideas that'll create new jobs, and it has new business models associated with it. Companies can think, what's the market I'm trying to create? How would I create a healthy market? How would it scale? And then I could take my 5% fee to make it monetizable. Quite valuable perspective. I'm going to skip that slide. All right, so the consequences for AI research should be less thinking about autonomy and robots that show off how they can behave independent of us, and thinking more about integrating with humans, using their data, making it transparent to humans so that humans and machines participate together in market economy, okay? It really has to do with value, and that's what markets are about. All right, so instead of businesses trying to create a service like search or something else on a platform, they should monetize this via a fee, not via advertising. Okay, so I'm going to skip that slide as well. Let me, in the last 1 minute, just mention that part of the effort here has got to be involving the real engineering of building large-scale platforms that do these kind of things. And academics has had an important role to play here. So in a project we've been doing at Berkeley, we've developed a platform called Ray, which is being used in companies like Amazon and Alibaba, Ant Group, and so on around the world in production now to do this kind of large-scale decision-making and market creation type of work. Okay, so I'm going to finish there. I had a few slides on Ray, which I'm not going to go over. Let me just say this is an open source project. It's international, therefore. It has collaborators all around the world. It's being used by many, many companies. And that is really part of the future of this discipline called AI. It's very international. It's not about one company or one country dominating. It's about developing open source projects. All right, so let me finish up by saying that I believe that what AI really is, it's the emergence of a new human-centric engineering field. So just like chemical engineering developed in the 40s and 50s from chemistry and physics, but it became a new discipline, how to create systems at scale that do chemical things. Electrical engineering developed 100 years before that from electromagnetism. It figured out new principles for creating electrical systems. What we have now is a new engineering discipline that uses data and algorithms and computers and markets to create a new kind of system that has humans together with computers. All right, so let me finish there. Thank you very much.
Well, thank you very much for the comprehensive and also very unique, interesting proposal on the direction of what others call AI. So I have until we get enough sufficient number of questions piled up from the panel, from the floor, I'll ask a question. So what your talk is essentially erasing the fantasy of singularity, right? So and then there's a lot of misconception at the moment. So it's hard to erase those misconceptions. What can you do? Do you have some ideas? Yeah.
So the people who work in the field of AI, I would say 99% of us don't believe the singularity is a thing. Okay, we believe maybe 300 years there will be a real deep understanding of intelligence in a way that makes a human-like intelligence possible in a computer, but it's going to take that long. So it's not really the thing we should be mostly focused on now. We should think about our existing systems. How can they be better? How can they help people? What are the principles to take them to the next level, and so on and so forth. So I think of it somewhat like science fiction. It's good to have science fiction. It's good. It inspires young people to think about where the world could be in a long time in the future. But at some point you grow up, you become mature, you become 20, 25 years old, and you say, what can I do to really bring value to the world? Algorithms, data, I got to think about how to do that. I got to have good engineering skills. I've got to be in companies organized to do these things. How do I do all those things? And what education do I need to have to be able to build these really large-scale, complicated systems that have these new kind of ideas? And dreaming about singularity and a new entity that sits there and is more intelligent than us is a distraction. It's a fun distraction, but it's for younger people to kind of get past at some point.
Well, thank you. Thank you for your answer. So then, the current AI paradigm is essentially, as you mentioned, is a pattern matching. It actually scales up, with the amount of data, then you can get the reasonable quality with this pattern matching, right? And then what you are suggesting is, as a next step, is essentially you're proposing the distributed agent architecture in a way, they can actually, function within the market. Is that right?
Yeah, no, there needs to be an architecture, but it's, I would resist the idea that it's just the architecture. It's somehow we need new principles. So think about electrical engineering, at some level, a lot was understood about electricity. There was Maxwell's equations. There was, a lot of understanding in physics about electromagnetism. But to think about how to bring power across a country, bring electricity into the homes, build circuits, build all the devices inside the home so the home didn't burn down and it really did what it's supposed to do. You needed new ideas like, circuit design and, impedance, matching, all the principles of electrical engineering that were developed over several decades. Those were needed to eventually have a really, really good thing called electrical engineering that does all the things we find so wonderful. And we're in the very beginnings of doing that for this discipline of AI. So we need architectures at some level, but we need new principles too. We need, how do you think about learning systems where things are changing slowly versus changing fast? How do you think about recommendations when there's cooperation or collusion? How do you think about pricing mechanisms at a new scale? All kinds of principles are needed to inform how we build these kind of architectures. One of the problems of computer science has been it's not really been out in the real world so much. It's been developing devices inside of the computer and thinking about compilers and logical principles to make those devices really, really airtight inside the computer, that they work as planned. And then you throw them out into the world and hopefully they'll do good things. All right? And sometimes they do and sometimes they don't. Really the better way in a few decades that we'll think about this is what kind of behavior would we like to have? What would we like humans to be able to have in the world of commerce or entertainment or finance? And how do we design the overall system to kind of deliver that kind of behavior? So part of it is building the architecture and having inside the computer. But when you have humans and markets and all, it's a lot of uncertainty. A lot of new things happen. That's the beauty of it. Is that, a new situation will arise, even like in something like medical care, like we're seeing with the pandemic. Every new day there brings some new things and new interactions and new people's experience of this thing and new ideas flowing around the world and all that. And that's kind of the spirit of what we're trying to capture here is how do you have data flow together with human thinking together with a real world responsibility, something like medical care.
So yeah, thank you for clarification. So so what we'll probably need is a kind of new thinking, a new maybe the disciplines. You mentioned the game theory, and then probably we need to get the economics in this game. So that means we have to also change the education. So what is your thought and proposal?
Yeah, well, I'll be talking this afternoon. There's a whole session on education, so I can say a little bit more about it. But I actually think that data science is a better terminology for what we need than AI. Because AI has too much confusion associated with it, as you saw in my talk. Whereas data science is more the flavor. It's taking data and thinking about it seriously. How do I make decisions even though there's uncertainty? How do I put together data? How do I deal with provenance? Is the data still relevant to my decisions? And thinking about building real systems like a medical system or a transportation system, those are the really core technologies that we need to develop. There's kind of a umbrella that incorporates certainly statistics and computer science and optimization, economics, but also reaches into nearby disciplines, genetics and medical and social science and law and so on. There's a whole range of things. And a good, even undergraduate student should be exposed to that. It's like the liberal arts of our new century. 200 years ago, there was no thing as liberal arts, that you would learn about art and literature and history all together somehow about the human experience. Now there's really no thing like data science, where you learn how to do some computing, but for computing for data and making public policy decisions in something like a pandemic and building a real system. How do you think that way? And you can. So I'll talk about that later today, but we have a whole program at Berkeley for the undergraduates that exposes them to computer programming, but in the context of data analysis and working on real world problems. And the beauty of it is that they love this. it's exciting to them because they can say, I'm trying to figure out, what's the problem with the water supply in my city, and I gather some data about it, and I do some good data analysis, and I write a program, and I can now diagnose what's happening in some interesting real world problem, and they love that sort of thing. So that kind of training, I think, is very much in the possibility. And it involves breaking down a few walls. It shouldn't be computer science over here, economics here, and statistics. It should be integrated. And so data science, to me, captures very much the spirit of what I think we should be doing. I do not think we should just be having classes on AI, because AI, narrowly construed, is too narrow and too confusing, and it leads to just wanting to build robots. And that is not really what we should be doing right now.
So for the audience at UC Berkeley, they introduced the freshman course called, I think it's the Data 8.
It's an undergraduate, freshman level class.
Freshman level.
Yes.
It's the foundation of data science.
19-year-olds, 18-year-olds.
Right. When you enter college, university, then you start with this foundation of data science class. And then I think right now there's maybe 1,500 students enrolled in the first semester. So, what this means, once students take this course, then the next level of course should also change.
That's
As a
very
ripple
good.
effect.
Exactly, yes.
For example, biology should be changed, and even computer science or statistics are changed. So then it dismantles the wars among the departments. So I think this is a very exciting model at the moment in the world. So I think you probably talk more about this in the afternoon. Yeah. So let me see whether we have some questions. The first question here is, what do you think about personalization? For instance, YouTube videos are recommended, but this worsens the polarization of political status, which is very, hot topic, in a way. Yeah.
Personalization is a terminology. It's been, prominent for about 20 years in business. It is critical. Personalized medicine is the future. It's already partly present now. Recommendation systems are a form of personalization, right? My shopping experience is personalized because of a recommendation system. And so, but it's not just a piece of technology. You throw in a little personalization and you're done. It's a style of thinking, and you can do it well or you can do it badly. So I think the click-through rate of Facebook is an example of doing it badly. All right, of trying to give someone a personalized news feed, and then having the number of clicks determine which pieces of news are shown to people. And it didn't take too much game theory economics to realize that can be gamed, and that's going to lead to phenomena where one newsworthy but false piece of news is spread to lots and lots of people. Okay. And I really think that Facebook should be critiqued. I think they really did a very, very bad job of building this news system, and really hurt humanity by doing that. And you could help undergraduates to learn that they should not be building systems that way, that they should be thinking about the overall social consequences of the system that they build. And so a large part of it is personalization. We do want a different experience. I want to be treated differently than everybody else. Right, but I want to do that in the context of a healthy system that allows us to connect up to the people that will give us value, and not connect things up just because of power differentials or because of things that seem exciting but are false.
So there's another question was, is really AI help people? Will it not be a threat? But I think. You also you answered most of the questions. This question, but speaking of your market idea, is this really a takeoff? In the presence of big tech companies like Google, Facebook, Microsoft.
So yeah, I don't think our threats are still, I think, people more than machines. I mean, people can take power. Like Trump took more power than he deserved, not because he was smart and not because he had supercomputers behind him. right? It just be old-fashioned power differential. And so it's very important that we make sure these kind of discussions are had openly, that we have everyone developing it, that it's not held by anyone. I should say that the ideas of AI are very simple, and they're publicly available on sites like Archive. All the papers are there. There's no hidden secrets. It's not the case that one company has got a better version of gradient descent than any other company. And even the data, some companies have a lot of data, but it's not always data that's so relevant for any new situation. What Google knows about me from all my browsing in the past is not that really relevant to my future, okay? It's not that predictive. And what a country really needs to be good at this stuff is not the super new algorithm or the bigger computers or the more data. It's really the engineering talent. It's really the HR. And so again, that's why I'm glad I'm at this conference to make this point. If Korea wants to participate on the world stage here, it's not by, necessarily having to develop anything more than just good engineers that really are able to build good, healthy, useful systems. And if you do that well, people around the world will probably take what you use too, and there'll be trade of these things. But it's really the building. It's not the ideas themselves.
Well, thank you for mentioning that. So, the last question, we are running out of time, but the last question is how we gain the competitiveness. I mean, in the previous session, EU, the former president said, EU is hopelessly behind. But how
I disagree with him.
Oh, yes.
Yeah, and that's one of the problems is that I have a lot of respect for him. He's done amazing things that none of us have done. But he's an example, just like Elon Musk and others who know nothing about the field of AI. And so you can ask him about that, and he'll have some opinion. But it's really not related to what's really happening. And so no, I don't think that's the right way to think about this.
So for the country like Korea to gain to lead, instead of the following, the U.S. You mentioned how we train the people,
How you train the people and pick a problem area, maybe it's art, or maybe it's human services, or maybe it's health. Something you think is really important to the soul of Korea, and focus on solving that real-world problem using all the tools you can, and develop engineers that do that. That's what I would recommend, and I think that's going to happen. I don't think this is going to be held by China and the U.S. I think Brazil will have their version of it, where they build systems that are useful for Brazil and Korea and so on. And then there'll be trade. We will see an era again where there's trade and there's openness of ideas expression, and it'll be prized.
The last question: what is the secret of nurturing these great scholars?
The secret of nurturing great scholars.
Yeah.
Oh, it's just to be humble. Recognize that the younger people are smarter than us. Okay? Help them to do the next thing, but we don't know, we don't have the answers. The younger people are smarter than us.
Well, thank you. Thank you. That's a great answer. So thank you very much. Let's give big applause to Professor Michael Jordan, who came all the way here. Thank you.
네, 고맙습니다. 진행에 수고해 주신 원장님께도 여러분 다시 한번 큰 박수 부탁드리겠습니다. 네, 고맙습니다. 열정적으로 또 함께해 주셨는데요. 마이클 조던 교수님께도 감사 인사 다시 한번 전달하겠습니다. AI를 새로운 영역으로 받아들이고 또 교육 또한 새로운 시도와 접목을 해야 된다라는 점 함께 느끼게 됐던 것 같습니다. 자, 이렇게 기조 연설 마무리하고 현재 시간은 10시 33분 지나가고 있습니다. 저희는 다음 순서를 위해서 10시 40분에 다시 시작하도록 하겠습니다. 잠시 자리 정돈 후에 저희는 기조 세션 1로 다시 인사드리겠습니다. 10시 40분에 시작하겠습니다.